Alright, this is topic 2.1, looking at example 2. We want to walk our way through this problem. It says Brian agrees to watch his neighbor's dog for 7 days. His neighbor provides 128-ounce bag of dog food. Does Brian have enough food to feed the dogs all 7 days? To set this problem up, what we need to do is we need to understand the rate of how this is. And we can use proportions or we can use ratios to help us set this up by looking at what we know and determine what we need to know. So, from the start, as we throw up the work here, we're going to use this idea of unit rates to figure out, right, the big goal of 7 days of eating. From here, though, what we're going to do is we'll start with Buster. Buster, we're given this information, 20.5 ounces in 2 days. Now, while that is a unit rate and it is a rate and it lets us know how the dog's eating, to get a true unit rate, we need something that is based off of 1, that increment. And so the first thing we have to do is we got to take this ratio, this proportion, and we need to change it into something that's equivalent to 1. So as we can see here, we want to know 1 day, since 7 days is what we're looking for. Since we're looking for 1 day, we determined that dividing 2 days divided by 2 is going to give us 1 day. Now if we do it to the bottom, we must also do it to the top. And so 20.5 divided by 2 gives us the results of 10.25 ounces. So this figure right here becomes our unit rate. From here, then, we can move on and solve the next step. The next step tells us that now we need to figure out how to do this for 7 days. So now we take our unit rate, which we've just discovered here, and we multiply it by 7, top and bottom, so that our fraction or ratio stays consistent or equivalent. And we come away with this, 71.75 ounces in 7 days. We're going to use the same technique when dealing with Roxy. The difference is we're looking at our days, and we have 3 days, so to form our unit rate we have to divide by 3. So by dividing by 3 we get our unit rate, and then we're able to multiply by 7 to get our new answer here. Now that we've determined how much each dog eats, we have these ratios that we can use. Now we need to find the total amount of dog food needed for all 7 days, which is going to involve the second step of the problem, which is going to be adding Buster's food compared and Roxy's food. And so over here we see very simple setup, adding these two numbers together and then coming up with a total of 124.25. From here then we can compare that to our bag of dog food, and we're able to then realize that Brian does have enough dog food. Right. That's our walkthrough of example 2. Alright, taking a look at example 3 then, and so we have 2 animals jumping different increments, but we want to know how many jumps would it take so that they cover the same distance. So this is going to take into a couple of different factors, and there's a number of different ways that we can solve this, but the way we want to use this is, since we're talking about ratios, we're going to use ratios. Now on your screen I've already done the slider, so we've revealed that a rabbit in 3 hops can jump 8 meters, while a kangaroo rat in 5 hops can jump 12 meters. So we've already been given that information. So how do we put that into a ratio that we can work with then? What we want to do is we're going to work with equivalent ratios. So we kind of continue working up the increments, kind of step-by-step relationships. So let's take a look at the rabbit's box to start. So over here we see that in 3 jumps it was able to travel 8 meters. Okay, so if that's the current pace, then we would say that in 6 jumps it's going to travel 16, right? 3 more jumps, 8 more meters. And then once again 3 more jumps, 24 meters. Now as we jump over to the kangaroo rat then, see 5 jumps is 12 meters. If we do another 5 jumps, so a total of 10 jumps, now we're at 24 meters. And suddenly we have a common number in distance, 24 and 24. So we can use this technique to just kind of fill in these ratio tables to continue to solve for this. And what we did in the end was we found the least common multiple between these two numbers, right? 8 times 3 here is 24, and 12 times 2 here is also 24. So we're able to use those numbers to come up with that. Now from there we can then take our data from this table to make our comparison, and saying that there are 9 jumps that the rabbit's going to take and 10 jumps that the kangaroo rat is going to take, and then they'll be at the same distance. Alright, it's your turn. Here is an example, and you'll find it in your book, so go ahead and use that space to solve this problem. This is it for topic 2.1.